we need to sketch f of x. So I'm going to start by drawing just simply the half x minus 3, and then we'll worry about the modulus in a minute. So that's got a y-intercept of minus 3, and it's got a gradient of 1/2. So it's going to look something like this. But if I do the modulus of that, that's going to take all of the negative y values, so all of these y values down here, and it's going to multiply all of those by -1 to turn them positive. So that part of the graph is going to reflect and now be like this. So that's the graph of the modulus of a half x minus 3. But I actually only want to draw that for where x is less than 4. So this part of the graph. So I'm going to rub this bit out. Next, let's draw the quadratic. I can see it's got a y-intercept of 17. I'm going to complete the square to work out its turning point. So I can see its turning point is at 4, 1, which is here. So the quadratic would look something like this and that. But it is only defined for where x is greater than or equal to 4. So actually I don't want this bit of the graph down here where x is less than 4. I only want that bit there. Just tidying that up a little bit. Right, that's part A done. Part B, find the range. So looking at the y values, I can see the smallest that y can be is 1. It can equal 1 when x is equal to 4. And then I can see that it can be bigger than 1. It's going to go up and up and up and up with no limit there, with no limit over here. It's just going to keep getting bigger and bigger. So there's no upper limit for what y can be, but the lower limit is definitely 1. So I'm going to say that f of x is greater than or equal to 1. That's the range. Part C. Find the values of f of 2. So when x is 2, we're using the modulus graph. So we're going to do a half of the x, which is 2, minus 3. Half of 2 is 1. 1 minus 3 is minus 2. And the modulus of minus 2 is 2. So f of 2 is 2, as we can see from our graph there. Next, f of 7. So when x is 7, we're going to be using the quadratic. So we're substituting 7 into that to get 7 squared minus 8 times 7 plus 17 which is 10. So f of 7 is 10. And then part D, solve f of x is less than 5. So here's where y is 5. So I need to find the values where f of x is equal to 5, and then I can find when it's less than that. So let's find this value of x here, first of all. That's where our modulus, half x minus 3 is equal to 5. Now remember that this part of the graph here did get multiplied by minus 1 when I drew it out. That did get reflected. So for me to solve this, I am going to multiply the half by minus 1. So I get minus half x, and the minus 3 by minus 1. Subtract the 3 from both sides, and times both sides by minus 2. So x is minus 4, as you can see from our sketch as well, so that's okay. Now let's work out the x value over here as well. So that's where our quadratic is equal to 5. So if I take my x squared minus 8x plus 17, make it equal to 5. If I subtract the 5 from both sides, and then factorise, I get that either x is 2 or x is 6. The 2 is not a valid answer here because my quadratic isn't defined for when x is 2, it's only defined for when x is greater than 4. The 6 is a valid answer. So my sketch wasn't particularly very good over here. My sketch should probably have been more like that. But no bother. In terms of answering this question, we're getting the correct values algebraically anyway. So f of x is equal to 5 when x is minus 4 or when x is 6. It's less than 5 in between those values. All this bit of the graph over here is where it's below 5. So that is where x is greater than minus 4 but less than 6.